Hi friends, welcome to the class 2 of heating effect of electric current. Before going to this class, let us recollect what you have studied in lesson 1 or class 1. Electrical energy is a form of energy which can be converted into different forms. And electric current is nothing but flow of electrons. To have a flow, there should be a higher electrical potential area or region or point and a lower electrical potential region. And electrons flow from higher electrical potential region to lower electrical potential region. The charge flowing per second is actually termed as intensity of electric current, where the charge is expressed in coulomb, intensity of electric current is expressed in ampere, and time in second. So we are getting the equation I is equal to Q by T. Then we analyzed a circuit where a battery and resistance are connected, and battery giving the power to the circuit with which that resistance is getting heated. And we understood that energy of that electrical energy from that cell or battery is converted into heat energy in resistance, and the amount of heat energy thus we calculated as H is equal to VIT. Now today we are coming to the next part of the class 2 or lesson 2 of that particular chapter, which deals with Joule's law. Friends, it is very important in the sense we have got mathematical part also in this. We have to solve some problems. We have to understand various aspects of or factors influencing the heat produced in a current carrying conductor. So we have to go in very specific manner in these particular points. Now, James P. Joule, he managed to calculate the quantity of heat energy produced or generated in a current carrying conductor. And he found out that heat generated in a current carrying conductor is directly proportional to the square of intensity of electric current, resistance of conductor, and time of flow of electricity. Mathematically, we can write H heat proportional to square of intensity of electric current I square, resistance R, and time T. And this can be written to calculate for that magnitude that proportionality is converted into equality. With a constant of proportionality, we make it as 1 if we take H in joules, I in ampere, R in ohms, and time in second. That is H in joules, I in amperes, R in ohms, and time second. If we use these units, we can write H is equal to I square RT, where H is the heat produced or generated in the conductor due to the flow of electric current intensity I through resistance R for a time T second. Joule's law, H is equal to I square RT, can be represented in some other forms too. For that, we have to consider the ninth standard topic. We have studied one law called Ohm's law. We have studied one magic triangle V, I and R. Why it is called magic triangle? All these things we have already studied, but we will just recollect it. What Ohm's law says is, in a current carrying circuit, voltage and current are directly proportional. That means if voltage is increased, current is also increased. V proportional to I, or we can write V by I, a constant. And this constant is termed as the resistance of the conductor, R. So we can write V by I is equal to R. This is called Ohm's law. Now the triangle gives easy method to see or to find out the values of V, I and R. For example, if we want to find out R, we just cover R. We get a formula V by I. If you want to calculate V, just cover V, we will get IR. And if you want I, we can write V by R. So we get 3 from this triangle at a glance, so we call it as a magic triangle. So in our H is equal to I square RT equation, we substitute this I and R, the value we are getting from Ohm's law. Let us see how it will change. We know H is equal to I square RT, H is equal to I square into R into T. We can write it as V by R instead of I square. That I square we substitute as V by R from Ohm's law into R into T. So we can write it again as V square by R square into R into T, where R and R get cancelled. We get equation V square by R T. This is another form of Joule's law. What we have done is we replaced I by V by R. Now next we can replace this R by V by R. Let us see. H is equal to I square itself into R we are replacing by V by I. This is from Ohm's law into T. Here I and 1I get cancelled and we get result as I into V into T. For convenience we can write it as VIT. Makes no difference. So H is equal to VIT. So we are having now 2 more expressions equivalent to H is equal to I square RT. So we can compare all these 3 at a glance. So as we discussed, now we are getting 3 equations, same one and the same but in 3 different forms. H is equal to I square RT, H is equal to VIT, H is equal to V square by RT, where H is the heat generated in joules, I current, intensity of electric current in amperes, R resistance in ohms, T time in second. Here all the same variables are there but in 3 different forms. As we have seen the magic triangle of Ohm's law, we can have magic triangle for this also. Before that, usually students get little bit hesitation to do these problems, as it is a mathematical problem, equations. They are a little bit doubtful how to go ahead with these equations, which equation we have to select, when we have to use h is equal to I square RT, when we have to use h is equal to VIT and V square by RT. We just listen to this or look at these three equations. Here the data variables I, R, T. T common, all these three we are having T. So if I and R are given in the problem, we can select H is equal to I square RT equation to calculate the heat generated in a current carrying resistor. Now, if we are getting voltage and current, we can select VIT equation. If V and R are given, we can write H is equal to V square by RT. Again, sometimes this direct calculation of H won't be there. H will be given, I will be given, R won't be given, T will be given. So we can calculate either H or I, R, V, T, all these from all these three equations. Then comes the problem. We will be all confused. So to get very easily all the mathematical problems answered, we follow a simple method which will give you some confidence in handling the problem or to address the problem. Otherwise you will just miss it. So let us see that magic triangle for Joule's law, like magic triangle for Ohm's law. I am drawing that triangle here. Here at the top we write H and it is divided into 3. I square R T. Now look at here, if we want H equation, H is equal to I square. As these three are side by side, we can write as H square into R into T. This is the equation. From this, suppose we want to get I, we can cover this part. That I directly we won't get, we are getting it as I square is equal to H is there, H, now divided by R and T in denominator, H by RT. From this easily we can calculate I, which is nothing but square root of. After simplifying H by RT, its square root H by RT will give you I. Now, if you want R, you can cover R. So R is equal to H by the rest I square and T. I square T. If we calculate I, unit of I must be written ampere. If you are calculating R, unit of R must be there ohm. Now last one is there T. So T is equal to, we know covering T we get the answer, that is H by I square R. As T is time, unit naturally will be second. So T second. So we calculate I, R, T from this equation. H directly I square R T. Is it not easy? Sure. Now comes next magic triangle of next equation, H, V, I, T. Actually, I need not explain you this thing, you will be writing yourself the answer. But I am writing H, V, I, T is there already. Now V is equal to, cover V, what we get? H by IT. Now if we want I from this equation, cover I, we get H by, then I2, V and T, so VT. And T is equal to H by VI. Obviously, V is in volt, I in ampere, T in second, H in joules. Now comes the third one. It is a little bit different from these two, but we can go ahead. H is equal to here one term is this V square by R. So we can write V square by R. And next is only T here. V square by RT. H is V square by RT direct. We can calculate. Then V and R are there here. So first we write V square by R is equal to, cover it, what we are getting? H by T. H by T. This is in the form A by B is equal to C by D. Immediately we get that cross multiplication process. We can cross multiply. V square into T is equal to R into H. Once we get this, easily we can calculate V from V square, T, and from this side R, H. Let us write V square is equal to, so simple, R into H. Now T divided by T. V square, T go to the other side, that is divided by T. Here into T will become divided by T. Simple mathematics. Next, T is equal to, T remain here, V square should go the other side, that means into V square will become divided by V square, that is R into H by V square. From this V square we get root of this V, as we have calculated I from I square. So we can write once again V is equal to root of R into H by T. And T is equal to R into H by V square. Then one more thing we have to calculate. H is equal to, that is directly given here, V square by RT. T, V and R. What about then R? R is equal to V square by T here this side divided by H. Again units same as these two cases. V in volt, T in second, R in ohms. Now this T makes some difference sometimes. T will be given in the problem in minutes or in hour. We have to convert this one into second. That we will deal in our next class, where mathematical calculations, taking one or two typical examples, how to calculate age, how to calculate the other variables, say I, R, V or T. I hope you got very good idea about this one, and these mathematical equations all you work out in a paper and list it, table it, don't make it by heart, but understand it. How we derive this equation. Actually, from that last lesson where we stopped is W or H is equal to VIT, which is that equation. James P. Joule made it as H is equal to I square RT. Nothing but substituting the Ohm's laws application. And here these three forms we can have for different situations, especially in mathematical problem. We are getting data. Sometimes R will be given, I will be given. Sometimes V will be given, I will be given. Sometimes V and R will be given. And these various combinations we will try in our next class.